In stats, we started 2 proportion z-tests. So very, very similar to 1 prop z-test. Now we're just taking 2 samples. So you start out the same way, except you're pretty much just doing twice the amount of writing. So you define group 1, true proportion of whatever that group is, and group 2, true proportion of whatever that group is. We're going to assume that both proportions are equal and that there is no difference. So we assume no difference. If you want to write that on the side as a note, you don't have to, but that kind of tells you how we're starting. And you're going to determine if it's less than, greater than, or not equal. For the planned step, and don't forget to define alpha. Probably 0.05. For the planned step, preferably you have random samples, but sometimes that's not possible, and all they do is say random assignment. Or both. That would actually be ideal. The large counts is pretty tedious because now there are 4 things you have to check. Here's group 1. Group 2. And if all 4 of those check out, you know the sampling distribution is approximately normal. Last little thing, sample size can't be too large, must be less than 10% of the population. But now there are 2 of these because you have 2 groups. All right, moving on to the do step. It's very similar, except we have one new statistic that we're finding, and that's a combined proportion. So first off, you can just write 2 prop z-test, or you can choose to write the formula, which is pretty horrible. Even if you know this formula, it is no fun to write. Make sure you write down the p-value. Make sure you write down all the other little pieces like P1 and P2 and what Z actually equals. And remember, you can write the name of the test or the formula right down there. I would write the name of the test. This combined proportion over here, that is all based on the 2 proportions being equal. Remember up in the null hypothesis, we're assuming the 2 are equal. That's why in the z-score, you're doing PC, the total successes over total subjects, because you're assuming that they're the same. It's one total proportion. So that's one reason why that happens. In the conclude step, compare P to alpha. You'll either reject HO or fail to reject HO. with context. All right, let's give one a try. It's about warts. Kind of fun, right? All right, maybe hit pause and skim through it. So we have a bunch of patients with warts. This group at the Madigan Army Medical Center is trying out liquid nitrogen freezing versus duct tape. And there was some article written, a real article written about duct tape and how it can remove warts. So they're doing two random groups, randomly assigned groups, and they're going to figure out which is better, which method. The method of duct tape looks pretty horrific. Something to note right here before I scroll past it is they were randomly assigned to the groups, but they were not random samples. It never says that. So they probably self-selected themselves. All right, so define your groups. P1, true proportion. I'm going to write small because we need the space. Of patients with warts that successfully remove them with liquid nitrogen. Group 2 is exactly the same, just with duct tape. Our two hypotheses, the null, we assume no difference. And HA, they ask it right above where I wrote, is freezing less successful? Is P1 less than P2? They don't give us an alpha, so let alpha equal 0.05 and move on to the plan step. We don't have random samples, but we do have random assignment. I have no idea why one group is 100 and the other is 104. Maybe 4 subjects bowed out for whatever reason mid experiment. I don't know. They don't have to be equal though. Don't worry about that. Large counts. If you're clever, you can see the results of all 4 checks right away. 60, 88, and the complements that add up to 100 and 104. If you don't see it, then plug it all in. It's a little more to write though. Because you do have to show the next line. You don't have to show the line that I'm writing right now. So what I was saying is if you see that for that first check, the hundreds cancel out and you get 60. The next one has to be the complement that adds to 100. The next one, 104s cancel. And the last one has to be the complement, 16. And that's it. I'm running out of room. Sampling distribution is approximately normal. We're going to assume that there are many people in the world with warts and that 100 is far less than 10% of all of them. And 104 is also far less than all of them. All right. Assume true. All right, move on to the do step, and I am kind of out of room. I'm going to squeeze it in up here underneath my two groups. So let's use a different color. We are going to find 2-prop z-test in the calculator and type in all our info. We need to write down p hat 1, p hat 2, pc, z, p-value, and I believe that's it. All right, let's find it. So go to menu, stats, stat tests. We have a 2-prop z-test. These need to all be whole numbers. And then make this match HA, and you're good to go. There's all our results. Let's write them down and conclude. By the way, third from the bottom, p hat, that's PC. If you'd rather write p hat instead of PC, you're welcome to do that. So p hat 1 was 0.6, p hat 2 is 8462. PC, or just plain old p hat, is 7255. The z-score was negative 3.9383. And I like to write it in my weird way here. I need more room. And if I go back to the calculator, look at the p-value. It has 4 zeros. We round to the 4th decimal place. Can't we say that's approximately 0? And then, I don't know how much the thing was paused. So there were 4 zeros. P-value is approximately 0. And compared to alpha, it is less than alpha. So we are going to reject HO. It just randomly paused. Maybe I accidentally hit pause. I don't know. Evidence suggests the true proportion of these patients, it wasn't a random sample, all right. I think that's it. See you later. Bye.